what we wanted to do today was we wanted to make that Colorado Springs experiment work, but using a different generator. So in other words, we took the spark gap generator that was designed for the Multiwave oscillator, we retuned it using complex advanced measurement techniques. For example, a vector network analyzer. We use that to assess the system, retune it, combine the two coils together, and then we were able to successfully drive that from the spark gap generator. With a single primary ring, and the other one is from the secondary and the extra coil.
Okay.
And we are right in the middle. It's just one of those things that happen to work out.
Yeah, well, I'm pretty good at generating that fluid.
Yeah, indeed. So let me show you what happens when I put 2 turns of the primary in,
okay,
and then we detune it. Like you said, I just crimped it behind it.
Yeah.
Put that in there. That changes us now to 2 turns. And what we're going to see. Okay, so
what is the amplitude there? Current?
This is
voltage, or
blue is the magnitude of the impedance.
Oh.
It just overlaid so we could see how the tuning moves.
Yeah.
So now if I put this effect here is coming off of the second harmonic, I think.
Yeah.
It'll be the second harmonic, which is
private, but it's kind of works. It's minus. It's sort of back and inverted.
It's a counter space thing.
Inverted counter space type thing. Yeah.
And that is at 1.55 megacycles.
Which one?
This one here.
Okay.
The upper one, I suppose we call that third harmonic. That is at 2.36 megacycles.
Yeah, that's definitely got to be, because there's nothing there that really resonates at that frequency on its own individually.
Yeah. So if I put the fundamental back on where it is now, which is 798 kilocycles, I'm going to take out 1 turn of the primary again,
okay,
and we get it better in match. That back in there. Now we're going to take another scan. We're going to see that primary go back up again.
Yeah, so obviously we got to go a little more to get it to land.
We could probably go a little bit, but the problem is you know when you get 2 coupled circuits.
The secondary neutral against the ground, that'll give us a more accurate representation of what the dynamics is, because the primary is throwing everything off.
Okay, let's give that a go in just a
See,
second.
the whole thing is you have to put basically a unidirectional pulse into the primary and disengage it.
Yeah, indeed.
Then the thing will operate properly. Otherwise, you have to take the coupling way back.
Yeah. Okay, so let's disconnect.
No primary.
No primary at all.
So connect your black wire to the one that goes to ground.
Okay.
Yeah.
So let's get this. Let's see. That's one side there. That's neutral. And then on the other side we can go on there. One side of the primary.
No. Let me do it.
One side of
Here, I'll do it. I hate these type of clips, they snag and everything. Okay, we'll just get rid of the primary altogether. Interference is all it is. This is the primary now.
oh, yes, okay.
This is stuck inside.
Yeah, no, I put that in far.
Okay.
But I can take it out.
Well, I want to get something I can stick in here.
Yeah, I've got something here.
Okay.
Okay.
There, now we can get an accurate portrayal of what.
Yeah, that would be great.
Find out how long that interference.
Just before we do that, back on there. I want to save that trace before we go further, so that we've got everything for later. Let me just take a picture of this. Save this. Got it for later.
Lips wire.
Is it this part?
Yeah.
Looks like solid string.
Well, it's because it's got a
The magnitude of the impedance,
Okay.
but it's so large.
But why the noise? It's receiving this AM radio station, maybe.
Possibly, yeah.
Yeah.
It's picking up, yeah.
It's picking something
Actually,
up.
that's probably the most likely. Let me just set the power level. Frequencies are about the same, though.
Okay.
That's 0. Black to green secondary. Okay, let's put the generator back in and do some running. I think we'll probably wants to get some sparks and stuff. Yeah, all those kind of things.
I'm going to write these two frequencies.
Yeah, let me tell you.
Frequencies down.
I will give you these traces anyway.
Now that's why they're askew. So it's like a quartz crystal.
Yes.
It's got two modes, series and parallel modes.
It's a series of parallel
It's
resonance.
acting like a quartz crystal.
Yeah. Yeah, I think so. Let me just auto scale that. Yeah, this is. Yeah, that's good. That's a good. That's a good expansion now, Eric.
Okay.
Let me just get this really to give you the parallel impedance. Okay, so the parallel impedance is 1.016 megacycles.
1076?
1016.
1016. Going to keep everything in kilocycles.
Yeah. And the impedance is 257k.
Holy shit.
That's actually pretty good.
Yeah.
For parallel resonance in this system's good.
Right.
Now the second harmonic.
Okay.
Let me just get the series resonance in the second harmonic is 1820. 41.9 kilohms. Good, we can save that. Alright, let's make some sparks.
Okay.
Let's get this primary bed set up again. Well, I've taken the lead somewhere. This one. Take that out. So we just tighten that slightly.
Make sure you twist those together. Get rid of the stray inductance.
Yeah, okay.
Less capacitance or less inductance. So that'll give you a little less inductance.
Okay, you twist those together.
Mm-hmm.
So let's do this up. As Eric said, make it nice and tight. Make it nice and tight. That's We were quite lucky, Eric, with the tune.
Yeah.
It's
Well, this
pretty close.
The start type stuff makes it pretty. So we got 2 times. You can up on the scale.
That's it. Yeah, we're fine.
Yeah, it doesn't have to be severe, but
Yeah, that's
as
the
long
real.
as there's no empty space.
It's the meaning of a twisted pair.
Screwdriver in again.
I think it's okay. Let's see how it goes first of all. Okay, so
Just the fan buzzing from the back.
Can you do that again?
Oh, there's a point on the top.
I put break that on there. It was in dark one over here.
Can you do that again? The top?
It was designed for the linear amplifier.
Well, but still, this is the, those are stress points that have to be dealt with.
Yeah. I think the spacing needs to be a little bit more there.
Yeah, that was, he said there was a problem in that somehow these something didn't work out right. The important thing is to get that shit off of there. So basically, this thing needs to be sprayed with Corona dope.
Yeah.
Heavy. From turn to turn.
Yeah.
Okay.
It went from turn to turn. So it went from down here down to this one, through the back, and then onto this one. But
so
then
it didn't become secondary.
No. It didn't jump from secondary to primary. I mean, if you make the spark gap less aggressive. I mean, what I did there was I made the spark gap more aggressive.
Yeah.
And then it starts really pushing it. You're bringing the voltage up with the gap bigger.
It seems like this probably should be rewound.
Yeah.
To get more spacing.
Yeah, it needs more spacing.
Yeah.
If you're going to run it from a spark gap generator.
Well, but the thing is, or turn the power up. I want to connect this thing to a 5 kilowatt AM radio transmitter.
Oh, you're going to need to increase the spacing. If you want to do that, you're going to need to increase the spacing.
Well, this is what, so this basically needs to be rewound for greater spacing.
Yeah. Probably new.
No, because we have the extra turns. You see, he just started off with one particular thing, but we can move these up.
If those were moved up and those one went every other one,
Yeah.
there would probably be enough.
Yeah, so that should compensate for it.
Yep.
Yeah, he told me what had happened. Somehow there was a mistake in one thing or another, but I don't know, it might be possible to just pull these and, I don't want to fuck the thing
Yeah,
around.
I think if we do it now, it's too much. Especially when you want to show someone.
So it can't be sprayed with Corona dope until everything's where it belongs, because it'll stick it in place.
I mean, the other thing also is if you want to go to that much power, is to rewind this with a PTFE coated Litz wire.
Well, this was already hard enough to find, so I don't think you're going to find any Teflon coated Litz wire.
I mean, you can get it. I've got some in the UK.
Well, then we probably should rewind it with that.
Because I was having problems with breakover in a cylindrical coil, and I rewound it with the Kynal wire.
Before I stick my hands in anything, I want to
This is off, but I'm going to pull it
off off.
Yeah, off.
Is we got to do the extra coil impedance.
Yes, that was including the extra coil.
Yeah, so the thing is to do the secondary by itself.
Yes, that's what we did yesterday.
Well, let's get that
Eric, we
written
did
down.
that yesterday as well.
Okay, but let's get it all written down.
Yeah, we can do it.
This is tubing. So
I wouldn't mind having a little break.
I don't know how to,
Having something to eat.
not quite fit in there.
We can connect it with a wire.
Yeah, I'm just trying to minimize the strays.
Eric, you could use that.
Okay.
Will it fit in the hole on the end?
Does it go in, Eric?
Yeah, it goes in too easy, unfortunately.
Well, try this one then. This one's got a ball on the end too. You might be able to ream it a little bit with that one.
That one's a little. Yeah, the tubing's just too hard. Yeah. So.
No, stop. Just space that out. Turn. It's a bit unbalanced. About the same. If I make the slot neck more aggressive though.
Well, actually, it's better to put slide that down and the rear back up. The rear back should be max, but the front back should be down. Shouldn't get a squeeze, right?
Get the maximum power through, yeah. Yeah, I have to give you a bite on there. I got this hand here. Lands high frequency. to get any more
No, this
configurations?
is Coil after.
Okay.
Yeah.
All right. I mean, we can bring them together.
Right side by side.
Yeah.
Side by side.
Well, it's a bit like the Landers experiment you did.
Yeah, right.
Is there any other tools or anything you want me to grab on there?
I think we were good. Is there anything? I think we've managed what we've got actually.
Okay.
It's good.
All right. Well, if you think of anything within the next hour and a half, text or have Aaron text me or whatever, and then I can be sure and bring it back.
Yeah, I think we should try connecting them together.
Doesn't hurt. See, there's supposed to be some copper strips to make the primary one turn, but I don't know. It seems like he grabbed
I know,
it.
he's taken, I haven't seen those.
Well, there's back here.
All right, I'm going to connect this back up again then.
Okay.
So we're going to do, so we can take a measurement.
I kind of like it up to a point, and then it gets irritating.
We're just going to do the
But
one
at first, I love the sound logo.
This is for the spark gap. He took the plugs, but he didn't take these. You got to figure out how to get these. These wrap right in here. They lay in here. I think what you need is some little screws.
We've got this, this is connected by screws.
Okay, well, here you go. These are your primaries for that. Then you can...
Perfect, that's even better.
Yeah.
Okay, then we'll just take those, leave them.
So actually, you might want to try, before you change anything else,
Yeah.
put one of these on there and see how it changes the operation.
Yeah,
So you
okay.
have something quantified.
Okay, let me just measure this one then directly. So, we'll use that as our reference. All right, so this is the vector network analyzer scan we have one coil here, ground connected, and we are feeding the measurement signal in. All right, so here we have a vector network analyzer connected to the computer and also connected to single coil, which is ground. Its secondary is connected to ground, and the network analyzer is connected to the primary feed on a single turn. So what we're going to do is we're going to take a frequency scan over the range 100 kilocycles to 3,000 kilocycles, so 3 megacycles. And what we see when we take that scan, I'll just sweep it again to make sure nothing's changed. We just wait for that to finish. Okay, so this is a typical frequency scan that you'll see for resonant air core transformer, which we're feeding the primary, we've got the secondary, and we've got the extra coil, and of course we've got the extension. So we're seeing everything all in one go. And this first peak here is the fundamental, and as for any system like this, it has both a series and a parallel resonance. So we can have a look at the frequencies of those. If we just put the markers on here, we've got a series resonance at 878 kilocycles. We have a parallel resonance. Let me just zoom in on that, get it right. We have a parallel resonance at 818 kilocycles, so they're close, which is good. It's a good indication of a good clean coil winding. And we're going to look at the second harmonic, which, let me just focus on this. So we're looking at, again, the Z11 impedance at the input of the coil system. The blue trace here is the magnitude of the impedance. So that's the impedance that the network analyzer sees, as it were, the generator looking into the system. And the reason that's important is because we're looking at how to match the generator with the coil system. So it's important we take a view of what the generator sees if it were connected to the system. And if we just move this marker in, first of all, there's 2 resonant points. So this relates to the resonance of the secondary coil, of the extra coil, and obviously with the wire length that goes up to the top. So first of all, we have at the fundamental a parallel resonance. Just going to zoom in on this, so we can get the marker at the point. And we're going to bring marker 2 into the series resonance. So the series resonance gives us a very low impedance, and the parallel resonance gives us a very high impedance. We're just going to get that right at the dip. That's it. And now here we have a readout of what those impedances are. So the parallel resonance is at 818 kilocycles. Yeah, it doesn't look like it's going to fit, so can you take that? It will allow us to join both of them and still keep the resonance. Could you just pass me there's a yellow-handed screwdriver. No. We're going to peel this off. Yeah, I think. I don't want to try and put it over the top. It might cause problems. That's pretty tight. Okay, so if you can put that over the top. Very good.
Oh, I missed that, damn it.
Did you want to? Okay, good. And then if you could take that at the back. Okay. Yeah. Hopefully. Okay, so we make sure it's located all the way around.
Yep.
In the right place.
See it all the way down here.
Good. And we're just going to. Okay, thank you. Start it there.
All the notches in?
Yeah, all the notches in your side?
Yeah.
Okay. Would you mind?
Yeah, I don't want to get shocked. Okay, so here we go.
Okay, so. We reconnect.
First time I ever got shot.
Reconnect this.
Was, over here, pissing on an electric fence when I was about 5 years old.
Then we're going to see
That's more fun.
how that changes on here.
Mine, I was playing with this little...
If you wanted to see something change, you could film the screen here if you wanted. I'm just doing it wrong. Our friends who are Tom engineers.
Oh, okay. Were you training at RF that long?
Yeah.
Oh, really?
Yeah, I've done research for 3 years.
Oh, wow.
Working there for a year.
Okay, yeah, because I haven't seen you before, and I was like, how do you know that other stuff?
Yeah, no, I didn't. And there's loads of
Oh, so you've been
Oh, yeah, no, it's touching points here. No, I can replicate all the stuff. Just
That's it's not touching. So.
Were you replicating it? Were you replicating it?
But well, yeah, it is on the ends anyway.
yeah.
Okay.
Yeah, I just built all the stuff.
That's
Yeah, it is what